Did I do the thing? Hey, I did the thing. We hit the button. All right, let's go. All right. So, hello and welcome. In case you're not sure where you are, this is Code Soul, hosted by Lunit. And today we're going to do an introduction to Golang. This is, as I mentioned offline, but for the purposes of the stream, this is going to be something between a cross between an introduction and a crash course. We're going to cover a lot. There's something like 30 or 40 slides, which is nuts. I usually make myself 20 slides, but we're going to burn through them really fast. We're not going to spend too much time on them. The first 3 or 4 we'll spend a lot of time, and then going through the code is just going to be like, here's how this looks, here's how that looks, and we move on. So quick introduction, especially for new folks. I'm Beege. I've done a whole bunch of stuff, backend, DevOps, data engineering, whatever. Worked at a bunch of different companies because I can't sit still for too long. But that's not important. It's just people keep asking, and I'm tired of saying it. So quick disclaimer, I am not an expert, all right? I love this language, but I'm honestly not the greatest at it because I haven't had as much time to spend on it as I would prefer. However, if you do put it on your LinkedIn, companies in Berlin will just be messaging you every damn day. It's nuts. But Golang is fun. I do like it. I think it's a great language, and I'm going to share with you guys why I think it's awesome, and I hope that can help you. But I am not an expert. I may not be able to answer all questions, but I will do my best, and if I don't know the answer, we can check it out together. Sound good? Cool. Also, when I get excited, I speak very quickly. So if I am speaking too quickly and you cannot understand me, be like, hey, calm down, okay? Also, when I ask if there are questions, I wait an uncomfortably long amount of time because I want to give you time to like think of your question, think of the words, and then summon the courage to actually say it. So if you have not been here before, be ready for that. It's going to be weird. Deal with it. But yeah, moving on. So today, long agenda. We're going to cover what is Golang. All right. We're going to cover when you should use it, in my opinion, not anything official, just what has worked for me. We're going to go over setting up a project. Surprise, it's very simple. Then we're going to go over writing your first program. And originally I was like, oh, we'll just write a tiny little program. And then I realized, oh, a lot of stuff about Go is different. So most of today's presentation is going to be writing your first program in giant air quotes. We're going to go through kind of a lot of the different language features that you see in other languages as well. So it's basically showing you the way things are done in Go. After that, we'll go over types and structs, which are unique to Go, but very similar to C++. Then we'll go over serialization, just because that's a very common use case. Then we'll go over concurrency, one of Golang's strongest aspects. And then we'll end with how to build Go programs, especially for computers not the one you're building on. And then we'll just cover some stuff of where to learn more. Just a bunch of links that you guys can use as a reference, and the links I used to build this presentation. So any questions about the agenda before we start, or anything that you guys want to see specifically that you're worried is not going to be covered? Told you it would be uncomfortable. All right, let's move forward. So, what is Golang? Golang is awesome, is what it is. It is a strongly typed language. All right, it is compiled. You can run from source directly, but usually you want to compile it into a binary. It is also cross-platform in that, well, I should have clarified that a lot when writing this. Not that a binary can be run on multiple platforms, but that you can build binaries for multiple platforms from just one source. I should probably actually remove that from the slide because it could be confusing and inaccurate. It has very strong concurrency support. A lot of people say it's like C++ with garbage collection and better concurrency. And on that note, it's garbage collected. It is also an open source language. You can go look up the source of Golang itself online. The language was created by Google and continues to be supported by Google to some extent, but it is generally an open source project. And when we talk about people who write Go, we call them gophers. And the mascot for Golang is the Golang gopher. You're going to see a lot of him today because he's adorable, and I didn't know what other images to put, and images are fun. So, any questions about what Golang is generally, like what kind of language it is?
You said like garbage collection. What does that actually mean?
Mm.
Like, I hope it's not very basic.
It's totally okay. So for online, the question was, what is garbage collected? So in kind of more deeper languages like C and C++, if you want to work with memory, right, you have to specifically ask for memory and then release the memory when you're finished with it. In many modern languages, Java is like the poster child for this. Stuff is garbage collected, where you just say, I need some kind of variable, and then the runtime, basically the environment of the program, figures out, hey, when is this memory no longer being used? And then if it believes it's no longer being used, it returns the memory for you. You don't have to say, hey, please give me memory. Okay, here's memory back. It just figures it all out for you. This is good because it's less work for you to do. But a lot of people don't like it because if you can control the memory more directly, you can be more efficient. So it's slightly less efficient than if you manage memory directly, but Golang's garbage collection is really good. So you won't see, unless you're doing like really, really, really deep stuff, you're not going to see too much of a performance hit. So does that make sense?
Yeah.
Cool. Any other questions? Also, if you think I say something not 100% right or you want to add more to it, go for it, because it's been a long time since I've done memory stuff. But that's true of other stuff too. All good? All right. So, when should you Golang? A big disclaimer here, this is just my opinion, okay? Maybe you would find a better use case for it, but when you need concurrency, I think Go is a great choice. Because it has primitives built into the language for supporting concurrency, which we're going to cover during today's presentation. Now that said, I'm always a little bit reluctant to use Go in Docker, because often when you're working with Docker, you're just doing a single CPU, right? So if you're doing a single CPU, concurrency is less useful. It can still be useful and good, but it's less effective than if you have multiple CPUs. However, if you just enjoy writing Go, like it's still good in Docker, whatever, it's fine. A language is a language. If it gets the job done and you know it, go with it. It does have fine control, but not to the level of C++. The discussion about memory earlier, you usually do not control memory in as fine-tuned a manner as C++ does. You're not saying give me memory, give back memory. So it gives you very good control, but not quite that deep. So it's kind of a nice balance area. It has, and on that note, it's fast, but you don't have to worry about memory management. It also interops with C and C++. So if you have some C program that you wrote, Go can communicate with it directly, no problem. We're not covering that today. That's deeper than introduction stuff. It's also, I mentioned cross-platform. If you need to build for multiple environments, hello, oh hey. If you need to build for multiple environments, Golang is great for that. Especially because if you look at languages that run in a virtual machine or in an interpreter, like Java or Python, you have to install the runtime there. But with a compiled language like Golang, you can just compile it for that platform. It produces a single binary file. You just send the binary file. You're done. As long as you can run that file, you're good. So on that note, it creates a big ease of deployment. Because if you compile your program, you just have one binary file you ship, and you're done. Maybe you have configuration files, or maybe there's environment variables you configure, if you're doing nice 12-factor app stuff. And you probably should be. But it's much easier to deploy than having to install a Python interpreter or install a Java runtime environment, this kind of stuff. Or if you just want to be awesome and cute like these gophers. So any questions about kind of those aspects of Golang? What's up?
Thank you. So you mentioned that we can run in Docker, but we cannot. It's not very efficient if we have more than one CPU. So does it mean that Docker cannot support like multi-CPU settings?
That's a good question. So I glossed over something very important when I was talking about Docker and CPU stuff. A Docker container can be allocated multiple CPUs. In which case, yeah, Golang is great if you're using multiple CPUs. It's also great if you're not, but it's particularly good at concurrency, which makes best use of multiple CPUs. But when I have seen Docker deployments happen, it's usually allocated a whole CPU or less. But if you're in an environment where when you deploy Docker containers, you're using multiple CPUs, yeah, whatever, go for it. Great, perfect use case. So does that answer your question, or is it a little different? Okay.
So it's possible.
Yeah, oh, it's absolutely possible. Especially like when you're running Kubernetes, you usually allocate. You have kind of resources that you allocate to a container, and you can give a limit of like they do it in milli-CPUs or something like that. I don't remember. It's been a while. And so you can say how much CPU you want to give. You can give it like half of the CPU time. You can give it 2 CPUs worth of time, and that sort of stuff. Now you can still do concurrency with a single CPU. It's just not as useful. But yeah. But again, like you don't have to do concurrency for everything anyway. Again, if you like the language, if your team is willing to support it, if it solves the problem well, then go for it. So does that answer your question then?
Yeah.
Cool. Other questions?
I do have a
Yes.
Speaking of intro with C and C++,
Mm.
do you think something like that are probably one of the examples?
So the
Like,
question.
Something like deep C on, like Rust or anything like that.
Uh-huh.
Like interacting with like Unix C functions.
Oh yeah, yeah, yeah.
Do you think that they can be one of the examples?
Yeah. So the question was, when talking about interop with C, C++, is it useful for like metaprogramming, things like this, or kind of how Rust do it, where you can use C libraries directly? I have not done a lot of it myself. As I understand, the answer is yes, but you should double check because I'm not very confident. I have seen it be done before, and it seemed like it was very good and very easy. Like I could understand it in that moment, but it was long ago enough, and I only did it one time, so I don't remember very well. But tentative yes.
Yeah, thanks.
Is that okay? Cool. Yeah.
There's something called Seago.
Yes.
Seago. So maybe that's related to Go and C.
Yep. Yeah. So CGO is the interoperability, whatever that word is, the ability to operate together between C and Golang. Yeah. So if you just look up CGO, you'll find it. Thank you. Other questions, comments, additions? All right, moving forward. I'm not waiting as long because I'm paranoid about time now. So, setting up a Golang project. It's so nice. It's so simple. Let's do it. So, create a project folder. Oh wait, that's not going to work, is it? Ah, oh no. Oh, I messed up my environment here. Here we go. Okay, great. So we're going to do this, and we're going to do. Oh yeah, don't look at my YouTube. I don't have weird taste. So create a project folder, okay? So I have a project folder here. I called it Intro to Golang Active. I don't know why I chose active, but it's because I had another one. Yeah, anyway. What am I doing? What am I doing? Terminal, new terminal. Here we go. And this will work for Windows too if you're on Windows. But then I ask why. But we're not, yeah. So I have my project, so I'm going to do go mod init. And what do I call this? Intro to Golang Active. I have a Go project. Whee! Done. Okay? So if we look at... can everyone read this, or do you need me to make it bigger? A little bigger? Okay, wait. Then we have other problems. Oh no! Can I get a... I want to do... Wait, really? It doesn't do top and bottom? Windows! I am disappointed. Well, sorry, guys. But yeah, that right there. Okay? So now, if we look at my file... Oh, God. If we look, you get this Go mod, right? And then, basically, that's all we need for our project other than a Go source file. So I'm going to do main.go. Okay? And now, if you're using Visual Studio, you can install the Golang extension, plugin, package. I don't know what they call it. It's actually really nice. I do recommend it. The error handling is very nice. The linting is very nice. It gives you all sorts of nice warnings and all that. But yeah, and that's it. Go source files end in .go. Main.go is usually considered the entry point. And that's pretty much it. And I'll cover why we do go mod in a moment. But, has everyone got this set up?
Beege, if you press Windows and you up arrow twice, it'll do a top and bottom. Just press it again. Yeah.
There we go. Thank you.
Oh my God, you're YouTube.
You were just trying to troll me, huh? But yeah, that's the command right there. So all good? Everyone's with me? Cool. So moving forward, let's go. Sorry, let me check that. All right, that was just the ice machine. So, we're going to go ahead and write our first Go program. I'm just going to copy and paste it from my reference here. And then you guys can just copy it to your stuff. And, oh God, where is it? Oh no, that's right. Ah. There it is. Okay. So this is, can I just make you smaller? Yeah, that'll work. So this is a tiny Golang program. Yeah. Wait, why do I have these extra new lines here? What's going on? All right. Oh yeah, why all these extra new lines? So this is a tiny Golang program. Okay. And oh, it doesn't. Let me get my terminal back. How do I don't actually know how to just pull up the terminal. I swear I know what I'm doing. All right, whatever. I'll just make a new terminal. That's fine. Yeah, whatever. So, oh, all right. I'll give everyone a minute to type that. And then, when you want to run it, it's quite simple. Yep. What's up?
You know, if there's any extension where you get what's it called, like autofill.
Yeah, so if usually once you save like whatever.go, VS Code will be like, hey, you're using Golang. Do you want to install the extension? And then you just say yes. Are you getting that or no?
I didn't get it, but I'm installing it.
Okay, great. So has everyone got this program written? I'm going to explain what it does in a second. But you can just run it by doing go run main.go. And it prints hello world in our wonderful, wonderful tradition. All right. Now, if you don't understand what the hell is on screen, I'm going to explain it in a second. But I want to make sure everyone's gotten to this point, that everyone can actually run a program. Is everyone able to get it to print hello world?
Yes.
This is where things go chaotic. Okay, so we got what sounds like maybe 3 or 4 yeses. Is anyone having trouble? You see, it's always tricky when doing workshops because it's like, okay, are people still typing to get stuff to work? Or are they typing because they're sending messages to their partner or something? I don't know. I'm going to assume everyone.
With 36 10-year-old Chinese students 3 weeks ago.
Oh, God.
That was great fun.
Yeah, that sounds like a nightmare. Good job.
I survived.
There we go. That's all we can hope for. All right, so I'm going to assume everyone's gotten at least this far. So let's go over. Oh, these aren't bound. Oh, that's kind of lame, actually. Oh, well. So let's go over what the hell is going on here. So in your source code, you'll see a package keyword. Package, this is similar to a Java package or a Python package. Usually, or a Java package or a Python module, not a Python package, because that is different. With the exception of your main package, usually the package reflects the folder name that it's in. So similar to Python modules, similar to Java packages, if you want to divide up your program into smaller modular components, you make a folder. That new folder is your package. At the top of your file, you say package and then the folder name. Very common. And it just makes imports more organized and easier. It's the standard way to organize your code for our newer folks. It imports packages. It's exactly like Python. However, do note that when you import packages, they are strings, which is a little weird. They are in quotes. And I'm going to explain why when we talk about dependencies. But for now, just be aware, when you do an import, it should be a string. It should be quoted. When you see func, okay, beyond being a wonderful style of music, func is how you declare a function. Okay, I got one laugh out of it. That was good. Func is how you declare a function, followed by a function name. And then, typical parameters, function body, all that kind of stuff. It does get more complicated, but we're going to get there in a minute. And then the FMT package is short for format. You will find when you start reading about Golang resources online, they hate to type. They use a lot of single character variables, and I hate it because it makes it impossible to read. But be prepared for that. It's mostly only with structure pointer references, but we'll talk about that later. But it is the FMT format is a standard library package for formatting text. Most importantly, it has the ability to print to standard out, like our print line here. And on the command line, Go is kind of your tool chain. So Go run runs a Go file. You can also do Go build if you want to build it into a binary. There's also, we did Go mod earlier to set up the project. There's a whole bunch of stuff like that. So any questions about the program that we have so far? Any questions about this guy beyond what I covered, or questions about what I covered? That made sense. Great. All right, so moving forward. Let's go ahead and dive into dependencies, because chances are, if you're writing a program, you're not going to write everything from scratch yourself. You're going to import some kind of library. So what we're going to do is we're going to add some dependency from the internet, and then we're going to use it, and we're going to see how this goes. So go ahead and follow these instructions, and then I'll follow them after you to update your program. And what this will do is this will install that dependency from the internet, and it will just work. And it's going to be beautiful. And you'll be like, why isn't every language like this? Can you guys read that okay? Do I need to make it bigger? Sorry? Okay. Thank you. It's always tricky because different people type at different speeds. All right, so at this point, I think people have a good enough idea. I'm gonna pull up my code so I can catch up. So I'm going to go ahead, and you're gonna see something funky here. It's gonna be great. So we're gonna do this, and I'm hoping that when something happened here, people got confused, and I'm gonna explain why it happened. And then you're going to be like, oh, that was confusing, but now I think it's really cool. So I have here this guy. You'll notice when I hit save, it went from 2 import statements to this thing. Okay? That's a really cool thing about Go. Go has a built-in linter. And a lot of IDEs will automatically use the Go linter to just format your code for you. So instead of having multiple import statements, they just have one import statement with multiple parameters, as it were. And it'll automatically format for me. So you don't have any of this stupid stuff about like, oh, we should use this linting style, we should use that linting style. It's like, no, you use the Go linting style. And it just does it for you. And you don't have to think about it. It's great. What's up? So this formatting is done by the Go toolchain, like the Go command line utility. Pretty much every editor that supports Go will use the Go toolchain to do this formatting. If it doesn't, maybe find a plugin. But it is kind of the standard way to do things. Cool. And then you'll notice that this guy here is all red. It's like, hey, could not import it. No required module provides this. Okay? So that's where we go back to our command line and we say go mod tidy. Mod is short for module, if you hadn't guessed already. And so what this will do is it'll scan your code and it'll be like, hey, are there any modules that aren't downloaded and imported and all this kind of stuff? Do I need to like clean stuff up for them? And yes. So what happened is it went ahead and it read my code. It read my code. It found this module on the internet. It downloaded it. And now it just works. So now I can do go run main.go again. And there we go. Very cool. So you just type your imports in your code, and then go mod will figure it out for you. Now, this go mod file here, right? This is kind of similar to like a package.json from like Node areas, or like a Maven or a pom.xml for Maven time, or all these sorts of things. It defines what Go version you're using, any dependencies, and any kind of additional requirements. But you don't touch this file directly. Just let go mod do it for you. Your code is the source of truth. Go mod reads your code and figures out how to write this file for you. All good. When we did go mod, I think it was init or whatever it was, that created this file, and then go mod tidy just cleans it up. So dependency management made easy. Now, the cool thing is that your dependencies can just be a GitHub repository, right? You can go to some Go library on GitHub and just be like, hey, I want to import like Cobra is a very common command line utility library for Golang. You can say, hey, github.com/ I think it's Cobra or something like that, and Golang will just like clone down the GitHub repository, set up the dependency, and you're good. Very slick. So you don't have to worry about like, oh, the Python package index is down or something, or like the Maven central repository is down. Like, no, there is no central repository. You give it a URL, it downloads it from that URL. Done. Make sense? Cool. So another thing to note, you'll see that, yeah, what's up?
Sorry to interrupt.
Yeah.
How did you generate the mod file?
So when we first started stuff, we did the go mod init, and then the name of the project. Yeah. I'll give you a second to type that. Okay, it looks like you got it. Yes. So the Go toolchain and the language are kind of the same thing. Yeah, let's get in the weeds for just a second while he's figuring that out. So the Go toolchain, if you just do go env, it actually does a whole bunch of stuff to kind of work, including like a bunch of GCC flags for various compile steps. It keeps track of where its current mod file is. It determines if interop with C is enabled. It also stores like where is Go installed, where can it find downloaded packages, what operating system is it using, all this kind of stuff. The whole tool chain is built into the command line utility. And that command line utility is included when you install the Go language support. Does that answer your question? Or your comment? All right. So, cool. Looks, Son, you okay? Great. All right, so going on. Now you might have, this is where we're going to start going fast. So you might have noticed, the format.println function begins with a capital P, but everything else was lowercase. This is a little bit weird when you first see it, but once you get used to it, it's kind of nice. In languages like Java, you have, private, protected, public, right? Or like package local, whatever that's called. In Python, you have to do like your init, and then you have to do your all. You have magic variables to kind of hide things, or like the double underscores to hide functions and these kinds of things. With Golang, it's much simpler. If a function or a struct or whatever starts with a capital letter, it's public. If it starts with a lowercase letter, it's private. That's it. You don't have to type any additional stuff. You don't have to say, oh, this is public, this is private. It just uses casing. So that format.println, the format module, the format package module, I don't even remember what we call them anymore. But basically the format library exposes a public method, println, and we know it's public because it begins with a capital P. That's pretty much it. Make sense? Cool. These are going to be real fast. So let's go into some of the more nitty-gritty stuff. Variables. So similar to languages like JavaScript, you want to, when you declare a variable, you have to use var, unless you initialize it at the same time, but I'll get there in a second. So you do var, variable name, and then the type, okay? And you can also do many at once. So I'm going to go ahead and demonstrate here. Hey. Okay. Hey, now it's doing the thing. Okay, great. So we're gonna, how do I, no, what? One of these days I'll learn how to use VS Code. So, where's my sample? I should do this. There we go. Beautiful. Okay. And I removed it from my sample. Good job, past Beege. Okay, anyway. So let's say, like, you know, I want to declare a variable. You can do it in here. You can do it at the global. You can do it at the package scope. You could do it at the function scope. Whatever. So I can do var x, and then I could say it's an integer. Okay. Nice thing is I can say whoa. Okay. You don't have to type this part. We're going to get rid of this in just a second. I can also say var x and y, and z, and they're all integers. So I can, again, you will find gophers hate typing, which makes me sad because I'm a fast typist. But anyway, you can declare many variables all at once. You can also do kind of like this, where you can see, you know, x, y. Let me comment this out real quick. Can do like x, y, z are integers, and then like name is a string, right? And so you can declare many of them all at once. Additionally, let's say that, you know, I don't want to have my I don't want to have my declaration and my initialization as separate steps. I want to do them at once. Well, gophers hate typing. So I could just do something like, if I don't want to do any of this stuff, actually, I'll just get rid of this because you guys have seen it. We're going fast. It'll be fine. I can just do x colon equals 1. Now that colon basically means declare the variable and then equals initialize it to this value. Okay? And then, nice part, Golang helps you keep your code clean. If you have unused variables, it will not compile. So that's pretty cool because that keeps you from making mistakes. Like, oh, I'll declare this variable, I'll use it later. And then you forget to use it later and goes like, you were going to use this variable, right? So we can do something like format.println x, oops, and 1. Whoops, I'm dumb. Typing is hard. Okay, so much for me being a fast typist. But now this will work. Like any other language, variables are pretty normal. There we go. X is 1. Cool. All right. Going on. Oh, no. No. I didn't want to go. There we go. So when we do this initialization, where you know x is set to 1, the type of x is inferred. Okay. In this case, it will infer that x is just I believe a 32-bit integer by default. You can declare that. I think this will work, right? Nah. If you wanted to declare it, if you wanted to declare the type explicitly, you would want to do this. Especially because there's like an int64, there's an int16, there's even an int8, there's uint8, all these kinds of things. Okay. Golang has a bunch of different primitive types, which is great. Did I get rid of that? I guess I got rid of it. Okay. Also, there are some slightly weird types. You'll see that there's a type called a rune. A rune is similar to like a character in C. It's basically a character from C. So you can convert back and forth between integers and characters, but that's a crazier thing that we're not going to cover today. So any questions about variables? Yeah.
So local and global difference in the everything which goes inside the main func is global, or not necessarily?
So scoping works the way you would expect, where if it's declared inside a function, it is scoped to that function. If it is declared outside of the function, like here, that would be at the package level. So it would be in the main package. Does that make sense? Cool. Good question. Any other questions? Cool. All right. On to functions. So, I really got to figure out a better workflow for this. Why are you not doing what I want you to do? Okay, fine. Be like that. So functions are a little bit funky. Normally when we write a function, we're used to saying, hey, function name, parentheses, type, parameter name, end parentheses, right? Go actually switches them. You do the variable name first and then you do the type. And that's because similar to how you can do x, y, z are all integers, you can do the same thing with parameters. So you can have parameter a, b, c, d, and say they're all integers, right? And so that's why they put the type at the end. Also, yeah, so that's the multiple parameters to a type. You can also return multiple results. You don't have to return just a single value. You can return multiple results. It is different from how it happens in Python. In Python, when you return multiple results, it actually converts those to a tuple. In Golang, you have to explicitly receive each result. If you don't, it's a compile error. Okay? So I'll demonstrate that in a second. Also, it has named returns. So you can name your return values at the function declaration, and then they're just variables available to use inside the function. And I'll demonstrate that in a second, too. Oh, I did have the thing. I skipped it. It's fine. And it does have variadics, so you can do like a ... to have multiple instances of a single parameter. And functions can be used in closures. So you can do anonymous functions. You can pass functions around as values, much like JavaScript, Python, most modern languages. So I'm going to demonstrate all this stuff briefly. So, okay, I guess you're going to make me do that every time, huh? So, if we, yeah, here we go. Oh, but now I have to do, oh, this is gross. Okay. So, let's say I want to have a new function. Let me define a new function here. And let's make this bigger. So I'm going to define a new function called add. It's going to take in two parameters, a and b, and they're both going to be integers. And then it's going to return an integer, because that's how an addition function should work. Okay? So you'll notice I can declare multiple variables at once, and if they're the same type, I can just put the type after them. You'll also notice that to declare the return type, I just put it after the parameters parentheses. Okay? And then you'll also notice I got a little bit of a red squiggly, or yeah, a red kind of error thing at the function termination. It notices it's a compile error because you have not returned an integer, even though your function declaration is returning an integer. So if we just do return a plus b, we're good. Okay? And then in my, I maybe should have organized this a little better. I can say, I can declare a new variable called add result, and I can say it is equal to the addition of 2 and 3. And then I could say, hey, go ahead and print my add result. Oh no, this is what happens when you blind type, boys and girls. Watching while you type saves lives. And this would execute. Actually, you know what? Let's go ahead and just let's stop being stupid about this. Give me a second here. There we go. Is that better? Oh no, what have I done? Okay. So now if we do go run main.go, you can see add result is 5. No big surprises. Everyone good with this? Cool. So now let's get a little fancier. I'm going to define a new function called add multiply. Typing blind sucks. And yep, typing blind sucks. And this add multiply function is still going to take in an a and a b. They're both going to be integers, but in this case, it's going to return 2 integers. Returning multiple values looks like that. And then I'm going to say, hey, return a plus b, and then return A times B. Okay? And I think it's complaining because I haven't used this function yet. Is that right? Yeah, it's not used, so it's complaining. So does this make sense so far? Does everyone understand the syntax? The comma separates the two return types. The two return types, or the two returns. The return types must both be integers in this case. So now, if I actually want to use this, I need to do, where's my sample? There we go. I can do add, multiply, sum, and add, multiply, product. And I can declare and initialize these to the output of add, multiply, 4 and 5. And then, why is that complaining? That's odd. Undefined. Did I mistype something? I must have mistyped something. Anyway, and then, you know, just to demonstrate, we'll print this, add, multiply, sum. Nope. And then we'll do product, add, multiply, product. And just to make this easier to read on you guys, we'll do this. There we go. Cool. Oh, Go doesn't like that. Okay. And then we will demonstrate here. There we go. Does that all make sense? Everyone following? Cool. Do people need more time to type, or are you guys okay? All right, we're gonna go forward. So back to now. I'm not gonna cover. Did I not? Okay, yeah, I did. Why did I do this in the next slide? Okay. And for named returns, I'm going to cover that in the next slide. So I'm not going to cover variadics, and I'm not going to cover closure. Or no, I am going to cover variadics too, but I'm not going to cover closures. Okay. But all this stuff you can find online. It's quite simple. So loops. So like every language, Golang has loops, but it doesn't have while. It doesn't have the while keyword, but you can still write a while loop in Go. Everything is for, because why do we have two different words to do the same thing? We just use for. Also, there is no for each in Golang. There are ways to iterate through collections, but the for each syntax, Golang doesn't have that. It's much more similar to Python's range stuff, which I'll demonstrate in a bit. Also, no parentheses, because Gophers don't like typing. And the initialize and the increment steps are optional, and I'll show you guys that in a second. Okay? Also, this guy's adorable. Look, he's waving at you. Okay. So, to demonstrate. Oh, no. Where's my... Oh, jeez. Okay. Nope, that's not what I was looking for. Nope, that's not it either. There we go. Okay, so what we are going to do is... I'm going to define a new function. So we're going to go, let me collapse these, because we don't need them taking up space. I'm going to define a new function called SumAverage, okay? And it's going to take in some numbers, and we're going to have a variadic input. Basically, we can take in any amount of numbers, and they have to be integers, okay? And then I'm going to say, I also want my outputs to be named so that I can work with them easily. I'm going to have an output named sum. I'm going to have an output named average, and they're both going to be integers. Okay, so here's an example of variadics and of named return values. Okay? Everyone's typing for a second, so I'll let you catch up. Cool, I hear the typing stop. So we're going to do our for loop. We're going to say for, and then this is going to be funky. I'm going to explain it after I finish typing it. You're probably like, Beege, what the hell is that? So this is range, okay, range works very similar to Python's range. In this case, the nums variadic parameter, okay, all of the numbers, all of the parameters that are provided get stored into an array, okay? And range will allow you to iterate through that array, okay? Range, when you call it, has two return values. The first one is the index, so 0, 1, 2, 3, so on and so forth. And the second one is the value itself, okay? Basically the value in the array. Now, the underscore, you might be thinking, Beege, you're a shit coder. Why are you naming a variable underscore? Underscore actually tells Go, hey, I know there's a value here, ignore it. Okay? So we're ignoring the index. I don't care about the index, I only want to look at the values. Okay? So we can do underscore to do that. If we wanted the index and not the values, we could have some name for the index variable, and then we could just do the value as an underscore. It all works fine. And then the value gets stored into num. So what I can do is I can do sum plus num, and then, because sum was already declared as my return variable, so it's already available to me. I do not need to declare it again. What's up?
Sorry, my brain starts to why we're spreading a type rather than spreading nums in the parameters for some method.
So how deep do I go? So I'll keep it as shallow as possible, and hope if it doesn't make sense, I'll go deeper. In this case, nums is a value, okay? What is stored in it is a variable number of integers. So that's why the ... the variable number of things, is applied to integer. Because num stores an array of integers in this case. So that's why the integer gets spread. Yeah. Does that make more sense now? Cool. Because I really did not want to go deeper. All right. So, yeah.
What's the nums after range?
So this is, right, I did not. So range, you can think of range kind of like a function. So, except it's not a function because there's no parentheses here, right? It's not an actual function call, it's a built-in. It's a built-in keyword. But what it's doing, range takes some sort of collection, in this case it's an array of integers, and it produces the index and the value, one by one. It's meant for using with loops. Does that make sense? Cool. All right, any other questions before we move forward?
Is something called slice? Or
There are slices, I'm gonna get to them later. But good question. Any other questions before going on? Cool. So, yeah, my uncomfortable waiting, we don't have time for that anymore. So, now we can also set the average to, you know, the sum divided by the length of the numbers. And then we have to tell it, hey, we're done, return. Give everyone a second to type. So a couple things to notice. Again, because the return values were named, those were declared automatically. We don't have to declare sum. We don't have to declare average. They were declared in the function signature. And then when we return, we just say return, right? Because the return values are already defined by those variables. So we don't need to do it, but we do need to tell Golang, hey, the function is done. Now, if you're thinking about like how you write languages, technically they don't need to, but that's, well, actually I haven't written a language myself, so maybe I'm wrong. But yeah. Anyway, you do have to include the return. I tried without it. The compiler was like, no. I was like, okay. So now let's go ahead and use that. Okay. Where is my, yes, that's much better. So now what I can do is I can say sum results, average results, initialize them to this, and print this. I'm gonna, oh, yeah, there we go, much better. Now people can see. Great. And if we run this, no surprises. You don't have to do that new line. I just did it because my screen is not very large for you guys to see. So. I think we're okay on time. We are halfway through. We're halfway through. Perfect. We're excellent on time.
Can I have a question, Beege, please?
Yeah.
So like that 3, 4, and 5.
Yeah.
How does the Go knows like this is collection or tuple or like list or like we just pass some, for example, every integer separated by comma.
Yeah.
But there can be so many options what this can actually be. Right?
Right. So that is the variadic bit. It says that we can have an arbitrary number of integers. So this means that we can have however many parameters, as long as they're all integers. Does that answer your question?
For example, if we can you please go to the sum average function.
Sure.
And here, like, if we separate these 3 dots and then we want a separate integer on the apart from this collection, is it confused or? For example,
I'm not sure. Let's try it. Yeah, it doesn't like that. What you would need, I believe what you would need to do is, yeah, you'd have to have your fixed number of parameters first, and then your last parameters have to be variadic. Because what's going to happen is the compiler is going to say, okay, these first n parameters, in this case this first 1 parameter, I know about and expect, and then everything else is going to go into that nums parameter. Going the other way around is harder. Does that make sense? You seem dissatisfied.
I've tried myself with some experience.
Gotcha. Cool. Any other questions? Cool. So, was that it for, right. So that was kind of a demonstration of kind of the loop stuff, but really I didn't do more? Okay, that's lame. This is all I prepared for loops, but this is, oh no, here we go. Oh, I did it out of order. Oh well. I'm sorry, guys. This is the first time I've tried to organize a workshop in this way, and I'm realizing this was not a good way. But experimentation is fun. So let's kind of do a more normal demonstration. Let's say we have a variable x as 0. Let's actually not use x because we already used x. Let's say y. And basically we can say for y less than 3. This is how you do a while loop in Golang. It's a while loop, but you use the word for. It's the same thing. And then we could do something like, format.println y. And then, the classic writing a for loop as a while loop, right? However, we can also do a typical for loop. We can say for I : = 0, I less than 3. Oh my god, typing is hard. I++, format.println I. And if we run that, no surprise. Scroll down here a little bit and bring this up. Cool. So while is the same, except you use for instead of while. And for is like a Java style or C style for. All good? Cool. All right. So moving onward from loops. I'm sorry that I showed you the hard example first, but okay. Nope, that's not what I needed. Oh my god, I should have cleaned up my notebook. Anyway, conditions. Pretty much the same as any of their languages with a couple of minor benefits. No parentheses, because again, Gophers hate typing. Also, you can include statements as part of your conditions. which is really funky the first time you hear it, and then you're like, okay, that's actually really cool. Also, Go does have switch case, but unlike other languages' switch case, it does not have fall through. If you don't know what fall through is, we're going to talk about it in a second. Okay? So let's go ahead and demonstrate, and now I'm in the right place in my notes here. So let's use that sum result value that we had earlier. So let's say if sum result is less than 5, you know, I should actually include the less than. Come on, Beege, learn to type. We can print like, oh, this is a meh sum. Otherwise, much like other languages, we can just do an if-else, right? We can do bigger sum. And we can have a normal else, so we can do format.println big boy sum. And if we run it, we get bigger sum. No surprise, right? Because sum is 12. Any questions on that? I think pretty much anyone who has passed Computer Science 101 is probably good with this one. All right, so moving forward, let's talk about the statement part. That's actually really cool. What we can do is, let's say we want to have a condition, but the condition should be based on some new value, and we only need that value for the duration of the condition. Basically, I want to generate a new value, and I want to check it, and then I'm done with it, right? And I also don't want to have like 50 lines to do things. We can do something like this. So you can include a regular statement as part of your condition. Now, those of you who are big into like readable code, at the beginning you might be like, heresy, right? But there are very specific situations where you should use this. For example, temp sum is not available outside of this condition. You'll notice it's giving me a value error. It's like, hey, that value is not defined. Whatever values you define up here only exist within the scope of that condition. Okay? So that helps keep things clean. Additionally, this is absolutely critical when it comes to error handling, which we're going to cover later. Okay? But any questions about conditions? Great, moving forward. So now, to answer the previous question, oh wait, no, I should pull up my slides. Slices. You have probably never heard of slices before if you've never worked with Golang. Slices are basically variable arrays. Okay? Golang has arrays, but arrays are fixed length. Okay? Once you declare them as some size, they cannot be changed. Slices are basically variable length arrays. Now, internally, they're using arrays, but all the resizing of the array and all that kind of stuff, they do it for you. You don't have to worry about it. Okay? So slices are basically variable length arrays. On that note, they do have a length and a capacity. Now, the capacity bit, that's more for like extreme optimization, because the way slices work is, again, internally they're an array. So their capacity is the size of the underlying array. So you can declare a slice saying, I'm going to have a capacity of like 10 values, but I'm only going to fill one value right now. Okay? And then under the hood, it's allocated an array that's size 10, but only the first value is filled. So if you check the length of the slice, it's just going to say, hey, I'm only one long, right? Because you've only put one value into it. But if you check the capacity, it's going to tell you, hey, I'm 10 long. Okay? Now, this is only really useful when you're doing like really, really fine-tuned optimization. In most cases, you're not going to care about the capacity. but it's good to know about. Also, there is a special function called make that you can use to produce slices if you don't want to create them literally. And you can use range as we did before. Actually, it's not a function. That's a mistake. Range is not a function. It's a reserved word. I will fix that later. You can use range to iterate as we already demonstrated. So let's go ahead and do a quick experiment with that. Oh, damn it. No. Oh, I just ruined everything. Yeah, it's fine. All right, so let's do a quick demonstration of that. Let's go ahead. Did I really do all of this? Oh my god. Okay, here we go. So let's go ahead and make a new slice. We're going to call it let's make a new. Yeah, we're going to make a new slice called sum nums. It's going to be a slice of integers, and we're going to initialize it with 1, 2, 3, and 4. Okay. Oh, whoa, not 4D, 4. There we go. So this is the syntax for literally defining a slice. Okay. And we can do, we can print this. And we can run that. No surprise. Okay. All good. So then we can also check its length and capacity. So we can say we can check its length and its capacity. Now, its length and its capacity in this case are the same because we defined it literally. We said, hey, here are the 4 values that will be in there. So under the hood, Golang was like, there's only 4 values. I'm just going to give them a capacity of 4. I'm done. Okay? So cool. No surprises. You're like, okay, so it's like more complicated arrays. Why? Why would you do that? You could do some other cool stuff, though. So who here has done Python? Cool. About half the room. Okay, more than half the room. Most of the room. So we can do Python-y things. Like we can say, hey, let's take the sum nums slice and let's replace it with a subset of sum nums. Let's basically go from the beginning of sum nums up to and excluding the third value or the index 2 value, right? And this works just fine. Again, we can print this. We can say, half of sum nums. Okay. Damn it. There we go. And you'll see no surprise there, okay, for our Python people. Okay, so we got the first 2 values of it. Great. But something interesting here. Let's go ahead and do this again. Oh, no, that was caps lock. That wasn't shift. There we go. So let's print the length and the capacity again. Interesting. The length is 2. The capacity is 4. Why? Because in the underlying array, we're basically using a smaller value, so we don't need to change the capacity, right? Memory is cheap. Well, no, that's not true at all. Memory is cheaper than CPU. So rather than allocate a new array of a smaller size, it's like, hey, this array is already big enough to hold the 2 values, so let me just keep the same underlying array, that's length of 4, and then let's only use 2 values for this slice. So that's why our length has been reduced to 2, but the underlying array, the capacity of the slice, is still 4. Okay, does that make sense? Cool. Now, let's make this a little weird, though. And this was due to some experimenting I was doing in preparation for this. I actually wasn't sure about this behavior. And let's kind of do, let's do this again. Let's call this reduced, okay? Now in this case, I'm getting from the second value, the 1 index of the slice, to the end. Okay? Now in this case, the slice is only 2 values, so it's just going to be a slice of the second value. Okay? But you would expect, you know, like I said earlier, the array is capacity 4, right? So you'll expect the capacity of the array to go down, or to stay the same, but the length to be 1, right? No! Why? That's weird, right? Who knows how an array actually works in memory? Old computer science stuff. Come on, guys. I mean, a lot of people didn't do this in university. So basically the way arrays work is it's kind of a list of memory addresses to where stuff is stored on disk or stored in memory. And the way that the allocation of the array works is you kind of just allocate, right, the size of the number of pointers. So then if you want to kind of reduce your set of pointers, it's much easier to say, hey, rather than have like, you know, I'm going to have a memory address starting here, I'm then going to store 4 pointers worth of values. Instead of like basically shifting all the stuff around, it's much easier to go, hey, I'm just going to start at the next pointer address and have 3 values. That's way faster. So that's why this behaves the way it does. Now, most of the time, you're not going to care about this stuff. But I thought it was interesting. I thought you guys might find it interesting. But most of the time, you don't need to worry about that. So let's cover the standard way of slice things. Let's go ahead and, where's my, yeah, there we go. Oh, this sucks. So let's use the normal way of defining slices. So I'm going to say I want a slice, and I want its initial capacity to be 0. I'm sorry, I want its length to be 0, and its capacity to be 3. Okay? So it's basically telling Golang, hey, give me an array of 3 and a slice of 0. Okay? And then we can kind of do this guy again. Does this work? I think this works. It does work. Spectacular. So we're going to call this the make slice. And let me actually... Oh, why would I do that? Beege, get your shit together. Sorry, guys, I can't type. And you can see that gave us a slice length 0, capacity 3. Now, the length and capacity parameters of this make function are optional. You don't need them. Okay? Wait, is that true? Wait, I might be wrong. I don't know. Let's try. Let's test it, because I don't remember. It's been a while. Yeah, no. Okay, you need at least the length. The capacity is optional. Okay? So you can say, hey, I need a slice starting with nothing. This is what you'll do most often when it comes to defining slices. Okay? You'll just say, hey, make me a slice of size 0. That's it. But you can optionally include the capacity, but you're only doing that if you're getting into like really hardcore optimization stuff. So then let's say, hey, I want to put some values in that slice. Well, I can't just start like saying, hey, index 0 is this, right? Because the slice is length 0. What you can do is you can append. And appending works a little bit weird. It looks like that, which I kind of don't like, but internally the way stuff works, it makes sense. So we can then, you know, I'm just going to print this for everyone's benefit. Typing is hard. Again, sorry for all the tooltips popping up and blocking things. Oh my god, I cannot type for shit. Okay, great. There we go. So this is how you add, this is similar to a Python append on a list or a JavaScript push on an array. Okay? That's how you do it in Golang. Use an append. I'm going a little bit slower than I expected, but that's okay. And then I also had here, yeah, I should demonstrate this too. Okay. And then the last part we'll cover for slices, we talked about range earlier, but I wanted to demonstrate it more clearly. So I'll I'll just clean it up. I know I'm blind typing, but I'll clean it up when I finish. Oh, wow. Oh, good job, me. We talked about range earlier, but I wanted to demonstrate the index part. Basically, this does what you would expect it to do. It shows the index and the value. So this is this is the approximate way of doing a for each. Okay? And again, if you don't want the index, you replace that with an underscore. If you don't want the value, you replace that with an underscore. You could theoretically replace both with an underscore, but why? But yeah. Questions about slices? Cool. I'm sorry. Oh, what's up?
It's not about slices, but
Hmm.
can we have list of lists and also
Yeah.
iterates with the list of lists?
Yep.
How can we do that?
So the question was, how can you have a list of lists? Basically, you would need to do I believe that. Yeah. It's a slice of integer slices. Yeah. All good? Cool. I'm just gonna I have my notes here that I'm gonna put online when we finish. I will make sure to put that in here too, because that's a very good point to include that I missed. So thank you. Any other? Yeah. I'm getting to that in a minute. Yeah. Other questions? Cool. Sorry that we spent so much time on slices. The capacity thing drove me mad because I was having trouble understanding it. So I thought maybe it'll drive other people mad too. So that's why I went so deep on it. But moving forward from slices, maps. So not quite objects, but we'll get to object-ish things in a bit. Maps, they're the same as Python dictionaries or Java maps. Honestly, there's not really. There is one really cool thing. So in a lot of languages, if you try to access the key of a map that does not exist, you get an error, right? Not in Golang. You do not get an error. Instead, it just tells you whether or not that value exists. So now that may not make sense, but I'll demonstrate it in a second. Also, the way you create the way you create maps, you can tell I've been doing too much Python. The way you create maps is the same way you create slices. You use make. Okay? The syntax is slightly different, but we'll demonstrate it in just a second. So, if we go down a little bit more, I'm going to create a new map called jobs. Okay? And, because they're similar to slices, I'm going to make. And the typing for a map looks like this. You use the keyword map, and then square bracket, and then the type of the key, followed by the type of the value. Okay? So the syntax, to be clear, is, get down here so you guys can see it. The syntax is map, key type, value type. Okay? And then we can say, jobs Beege is PM, and then we can go ahead and print that. Let me just do my standard style of doing it here. Okay. No surprises, I expect, right? Everyone good? Kind of boring. It's about to get really cool. It's a really simple thing, but you're going to be like, that makes so much sense. God, I love this language. One more time. Yeah, so the brackets indicate that's the type of the key. Yeah. And so that way it knows, okay, the type of the key is going to be string, the type of the value is going to be string. Let's actually change this a little bit just to make that clear. Let's do let's instead of jobs, let's make this ages. I'm gonna tell everyone how old I am. Yeah. Whatever. It's fine. And then let's make this. Let's be fancy. Let's make it a uint 8. We're gonna hyper optimize stuff, right? Because you can't have a negative age, and no human's gonna be older than 255, right? At least for now. Hopefully someday in the future. Now you'll notice it's giving me a type error here. Good, because the type has been declared as uint 8, so it should be an unsigned integer of 8 bits. So I'm gonna, you know what? I'm not gonna tell you my age. I'm just gonna tell you I'm 21, because I can totally pass for 21, right? Yeah, totally. And you know, no surprises. So is that a little bit clearer for the brackety thing? Cool. All right, questions about this part so far? All right, now for the cool part. Oh, sorry, actually not quite yet. There's one more thing I want to show. Let's say that you don't want to have these as 2 separate steps. Let's say that you want to do it all in one step. You can declare a map literally, similar to how you do with slices. And it looks like this. Wait, what? Huh? Why? Oh, right, sorry. There we go. And then, you know, we can print that too. Good. Cool. So now for the cool part. So, let's say I don't already know the values in my map. I want to try to get the age of someone named Gildong, like Hong Gildong. Okay. What I can do is I can store the job value, right? And then I can check if he exists in the map. Ah. Oh, it's jobs, not ages. I'm sorry, I'm going off of my example here. I changed it on the fly. Ah, sorry guys. Sorry. I hope no one had typed that part yet. Why is it complaining? Oh, because I cannot. There we go. Great. It's so simple, but it makes me so happy just because it makes so much sense. So I'll give everyone a minute to type, and then I'll explain what the hell is going on here. Yeah, I think we're still good on time. Gildong. Hong Gildong. Oh, there's people online! Oh, I'm so sorry. Kind of missed that half the beginning. Is Go language object-oriented programming? Crap. Kind of. So, sorry, there was a question online, and I was not paying attention to online. I am so sorry, Kundong. Kind of. Where I will let you be the judge of that when we get to types and structs. But anyway, I think everyone is done typing now. So, this right here, when you access a value in a map like this, it actually gives you 2 values, similar to when you return multiple values from a function. The first value is the value you tried to get out of the map. And the second value is whether or not that key exists in the map. So in this case, Gildon, damn it. That's why someone said Gildon. Okay, thank you. Sorry I missed it. So Gildong is not in our map. Only Beege and Susan are in the map, right? So what happens is exists gets set to false. And so remember earlier when I talked about, hey, you know, the readability of this condition stuff is kind of weird? Well, in this case, it actually makes sense because we only want that to exist or we only want that variable to be alive in the scope of this condition. Okay? So we try to grab the value. If it exists, we do something with it. If not, we print it does not exist. Okay? This, in other languages, what you would instead do is you'd either like do some other type of existence check, or you'd have some kind of error handling, right? Like the Pythonic way would be to like try to access it, wrap it in a try-catch clause, and then like, you know, print out, oh, there was a key error, right? And then continue with whatever. But in Golang, no. They just have it as another value. So does this make sense? Cool. I love this stuff. It's just beautiful to me. But sorry, I will try, for online folks, I will try to look at the online questions more. I am so sorry I missed. I got to fix up my environment. I need to figure out how to use this wonderful new monitor that someone set up, and I've been asking for it for a while, so I need to figure out how to use it. But yeah, so any questions about maps? Because that was it. Cool. So back to, oh God. Oh, defer. Defer is great too. So you ever try to like read a file, and you know you open the file, you do your work with the file, and then you forget to close the file, and then you're like, why does my program have a memory leak? Right? That sucks. Right? Has anyone done that before? Cool. I was really glad at least one person said yes. That's kind of a common thing. Defer is meant to solve that kind of problem. Defer basically says, hey, take whatever this statement is and run it at the end of the function. That's it. So, for example, if you're opening a file, you can open the file and you can say defer, close the file. And then at the end of the function, it will look at the defer lines and it will execute those and close the file for you. It is beautiful. And I don't know why no one else did that sooner. Or maybe they did and I just didn't know about it. One thing worth noting, defer acts as a stack. So your earliest defer statement will be executed last if you have multiple defer statements. Okay, it is a stack, not a queue. First in, last out. And as mentioned, it's really good for when you want to do cleanup, and it's particularly useful to keep relevant logic grouped together. Okay? So let's go ahead and demonstrate that real quick. Oh, no. Oh, I clicked on the wrong spot. Yeah, I really need 3 monitors with this workflow. Okay. Slide 18. Code is here. Okay, great. So let's say, you know, and it works very simply. You can just do defer and then some statement. Whoa, Beege, learn to spell. Okay. Whoa. Okay, there we go. No, oh my God, I cannot type today. It's because like twisting your body and then typing is not fun. And then I can do something to print out a bunch of stuff just so that you can see the order in which things are executed. You can tell I have a typo here. Whee! Okay. What? Oh. Yeah. There we go. And now, when we run this, you'll see deferred gets executed last because it gets executed at the end of the function. Okay? So, very simple, but incredibly useful. Questions about defer? Because that was it. So, yes, you can use multiple defers, and each defer will be added to a stack. So the first defer will be executed last. The last defer will be executed first. First in, last out. So you can stack up a whole bunch of defers, and then at the end it'll just... Good question. Other questions? Checking online too. Oh, Tia. They put a hand signal like this. I don't know if that means they're trying to ask a question or if they're waving. Well, I'll wave back if it's a wave. If it's a question, just ask your question. Yeah. So that was it for defer. That's it. And then errors. You'll notice we haven't done any error stuff yet. Errors in Golang are funky. They're weird, but they're kind of cool. Oh, what happens when deferred throws an exception? Ooh. So, I'm going to defer that question. Let me talk about errors first, and then I'll answer that question. So errors. First off, errors in Golang, they are a primitive type. Okay, they're a type, or primitive? No, they're a struct. I'm pretty sure they're a struct actually, but they are a built-in type. Errors are not a special thing though. They're just treated as a variable. There are no exceptions. Okay, errors are just another variable, another value. This is a little bit weird to think about, and it changes your workflow a lot. And that means there's no try-catch. There's no try-catch and go. Okay, but then those of you who have been doing this stuff for a while, you might be thinking, but Beege, then what the hell do you do for a runtime error? Well, there's panics. Okay, panics are kind of like a seg fault. Not quite, but they're a little bit like a seg fault. And you can recover from panics, but it's not recommended. Instead, it's basically like the response to like, well, how do I like catch panics and resolve them? The response is usually like, write better code. So we're going to jump into errors real quick. And I'm also going to demonstrate a panic. Okay, so this is slide 19 now. And here's my code. Great. So I'm also gonna show you a nice little built-in library function here, and we're doing great on time. So let's have some integer value, okay, and then let's also have an error. Okay, so now this is a library, right? So in VS Code I can do control dot. And I can say add the import, and it just does it automatically because modern development environments are wonderful. Okay, so this A2I function, okay, it's short for alphabet, like a character, like a string, to integer. Okay, so this is how you convert from a string to an integer, basically, in Golang. But there's a chance for that to fail, right? What if the string is not a valid integer? What do you do? In other languages, you would throw an exception. And then you do like try catch stuff. But in Golang, it's like, hey, if you're expecting this to happen anyway, why does it need to be some special type? It could just be a variable. So let's just make it a variable. So the A2I function returns the converted value if it could successfully be converted, and it returns an error, which could be nil, which is Golang's none or null. Okay? So let's check this out. Let's go ahead and print that. Okay, and then, yeah, so let's run that real quick. So you'll see the value is -4 because, you know, that's a string that could be validly converted to an integer, so that's all good. And the error is nil. There is no error. Okay, so it's nil, so we can continue on our way. All right, so far so good? Cool. So, but what if that was a bad conversion, right? Let's go ahead and do that. So let's do integer value again. But this time, let's make an invalid string. Let's make it A, okay? So we're going to try to convert A to an integer. What do people expect to happen? In another language, what would you expect to happen? It would blow up. It would throw an error, right? But we don't have errors. Instead, we have an error variable. So what do you expect to happen?
You get no value, and then you'll get like an error message.
Yes, you'll get no value, and you'll get an error message. So to be more specific, the integer value will be nil, and then the error variable will have an error-typed object. Object? No, I'll call it object. Why not? Okay, so let's go ahead and demonstrate that. And there we go. You'll notice our deferred is still there too. So now, why is the errored value 0? Because the integer type cannot have a null value. The 0 null value for an integer is 0. So that's why it's important to check your error variable. Otherwise, you'll get false zeros. Okay. So that's basically how you do error handling. If an error can come up, it'll be output as a result of the function.
You can't change that. Like, you're always going to get a 0 when it comes from an integer, right?
Right. So the question was, you can't change that. The 0 value for an integer is always going to be 0 rather than nil or something. Yes. And that's why it's important to check your errors. Golang makes stuff like super convenient and super clear, but it also is like, hey, don't mess up. So it has a lot of hand-holding, more hand-holding than C, but less hand-holding than Python, if that makes sense. Okay, so any other questions about error handling? Because that's it. Errors are variables. Done. If a function can throw an error, it will just return it as a possible variable. Okay? All right, so time is...
Deferring the demonstrating next.
Sorry?
Shouldn't we be deferring the...
No, I just printed these to show that this would be printed after these. Yeah. So let's say delaying defer, I guess. Or, I don't know. Yeah, I'll figure out a better way to write it to make it clearer later. Not deferred. There we go. Thank you. Much better. Cool. Deferred. Yeah, there we go. Thank you. So, moving on. Now, let's. Okay, let's get into like the actual new Golang stuff. It's because he's adding structure to his abs. So I'm sorry, I just had to. So types and structs. Who remembers pointers from computer science class? Oh, cool. I know we also have a lot of people who didn't go to university for computer science. You are at a disadvantage, but you're going to catch up now. It's going to be great. So for those who are not familiar, a pointer is, rather than referencing the value itself, you have some number, usually represented in hexadecimal, pointing to where in memory that value is. So that is what a pointer is if you are not familiar. Now, structs are very similar to classes, but they're not classes. Okay, structs are not classes, but they're very similar. So this is so the question online of like, is Golang object-oriented? It's kind of a gray area. Oh, sorry. I forgot to answer the deferred throws an exception thing. So to catch you guys up, online there was a question, what happens when deferred throws an exception? Because there are no exceptions, it's just a variable, like your deferred function call should handle that. But usually it's weird to defer something that can throw an error. But chances are that if whatever you're deferring is throwing an error, but it's at the end of the function, you probably don't care anyway. So yeah, that's kind of, I hope that answers your question. But back to the types and the structs thing. So again, they're not quite classes, but they're very similar. And there's also type aliasing. So the built-in types, you can give them a different name, and then you can kind of add to them. It's kind of inherentancy things, but not exactly. When you construct objects, quote, I'm honestly not sure whether or not to call them objects, but I'm going to call them objects because I don't know what else to call them. When you construct objects from structs, much like you construct objects from classes, you can either do it as like a dictionary or a list. I'm only going to show you dictionary because that's much more readable. And then there's also interfaces, much like interfaces in other languages. They're kind of similar to interfaces in Java, actually, if you have done that. And polymorphism, if you're familiar with that term, is also supported, and we'll demonstrate that briefly. But let's dive into structs very quickly. So I'm actually going to make a new file just to keep things clean. And I'm going to call it something I don't remember. I'm going to call it structs.go. Oh no, what have I done? What have I done? Nope. Beege, learn how to use a computer. All right, going to make a new file called structs.go. And, I'm going to do package main. I know I'm going to need format, so I'll go ahead and pull that guy in. And it's going to complain because in another file in this main package, I have defined the main function. So it's like, hey, you're defining the same function in 2 different files of the same package. It's basically a name collision. But I'm executing the file directly, so I'm just going to ignore that error, okay? And then we can format print, works, whatever. And then we can do go run structs.go. Cool, right? No surprises here, whatever. Moving on to fun stuff. So, actually, I'm sorry, guys. We're going to go a little bit over time, but not too much. Yeah, I probably should have cut all the slice stuff. Anyway, let's go ahead and define our first struct. So, what I'm going to do is I'm going to define a new struct out here in the package scope, which is usually where you have to do it. Actually, I think that's the only place you can do it. I'm going to define a new type called person, and it's going to be a struct. Hint, if you're curious about type aliasing, you can probably guess how that works based on this line. And this struct, it's going to have a name, and that name is going to be a string, and it's going to have an age, and that's going to be uint8. Also, did you notice it auto-indented? That was wonderful. So this is kind of similar to a class definition when you define the instance variables of a class. Okay. But it's not like a class because there's no class variables or anything like that. All right. So structs are not classes. Do not get confused. Now let's go ahead and make a person, which out of context sounds no. Anyway. Going to make a new variable, myPerson. I'm going to declare and initialize it to a new person struct where the name is friendo, because he's my friend, and the age is going to be 20 because all my friends are way too young. It's actually not true, I hope, but yeah. Let's scroll down so you guys can see better. And this doesn't need to be as big anymore. And then we're going to do something like format.println person and myPerson.name and aged myPerson.age. Age with a capital A. Now, real quick. Why do name and age start with capital letters? Does anyone remember? Public variables, yes. So people outside of this package could access them. If you wanted to do it Java style, and have them be private, but then have getters and setters, you could totally do that. Just set the variable names to lowercase, and then define a function to do the getter and setter. We'll cover the function definitions on structs in a minute. Okay. But if we run this, you'll see person friendo age 20. Okay. Hopefully no surprises here. Pretty simple. Oh, I didn't put an order on this. Yeah, we'll do that one first because the other one doesn't make sense. So that's all cool. But now, what if I want to pass that to a function, right? What if I wanted to pass myPerson to a function, but I wanted to be able to modify myPerson from that function, right? So in not pointer land, we call this passing by reference or passing by value. Okay. But when we have pointers, you would just pass the pointer. However, you can also just store the pointer in the variable directly. So let's go ahead and demonstrate that first. So let's do... Why did I do that? Okay, anyway. Oh, that's why I did that. Okay, so let's go ahead and make a pointer person. Person. And let's make that a pointer to a person. So what we're going to do is I always get this terminology wrong. I may not say this correctly, but I think it's dereference a newly created person object. We're going to name them pointo. because I am great at naming things. They're going to be 30. And what we're going to do is we're basically going to do the same thing, but instead it's going to be pointer person. Okay, let's also make this go away. There we go. And no surprises. Okay? So far, so good? For those of you who are familiar with pointers, this might be a little bit boring, and I apologize. But for those who are less familiar with pointers, I think this is quite helpful. So we're going to spend some time on it. Now, you might be thinking, Beege, they print the same. The hell's your problem? Well, they are different things. Yeah, we'll do it that way. Let me also, to be clear, let's add a new line there. Let's do my person. No, let's do, there's a library called reflect. Okay, that's for doing reflection, basically the code looking at the code. And we're going to do type of my person, and we're going to get the kind of that type. Okay, and then we'll have to import this guy here. So control dot import that. Why did it scroll up there? Okay, there we go. And then let's do the same thing for pointer person. Okay. If we run this, you'll see that one is a struct and one is a pointer. They're two different objects. Okay? Now, mostly I just wanted to do this so you could see how to do reflection. However, this is not how you do type checking. Okay, there's a different way to do type checking. I'm not going to demonstrate it today, but it's very simple. You can look it up online. Okay. Now, I'm not going to demonstrate it because we're getting tight on time. But let's say I have a function, okay? And it can, let's say I have two versions of a function. One takes in a pointer to a person and one takes in a person, okay? The one that takes in a person will get a copy of that person value. So if I modify that person value, the original one from where the function was called will not be changed, okay? Because when you pass by value, when you pass just a person normally, it's just passing a copy of the data. If I have a pointer to a person, and I pass that pointer to a function, and then that function modifies the pointer version of it, the original person gets modified, okay? Because what it does is the pointer is a reference to a location in memory. So what you do is you basically follow the pointer to the location in memory, and then you mess with that, okay? Whereas when you pass without a pointer, it's just passing a copy. The copy is independent. Changes to it don't affect the original, okay? Does that make sense? Yes?
Does that mean we shouldn't pass by reference in code? Just like JavaScript?
So it depends on what you need. For efficiency, so passing a pointer will be more efficient, but then you have risk of modifying the original.
How does that work with like primitive values?
Same thing. Yep. Primitives can also have pointers to them. Yep. So basically, if you, in my understanding, and then when I have written Go, I usually default to passing a pointer for struct types, unless I want to guarantee that a copy is being sent, just because passing a pointer is faster. For primitive types, like an integer or something, like it's an integer, it's tiny, who cares? A pointer is like integer sized, so whatever. So does that make sense? Cool. Now there are cases where you will not want to use a pointer, when you actively want to pass a copy or you want to make sure that the original value isn't modified. And so in those cases, you just pass the value and not the pointer. So just something to be aware of. Yeah, we're going a little bit over time. I apologize, guys, but I'll try to go fast. So why did I do this in this order? This is dumb. Oh, that's okay. No, that does make sense. So cool. Let's go back to actually defining the person. Oh, no, I skipped that part. Right. Let's not go back to defining a person. So, cool. We can put variables in a struct, and then we can pass that struct around like an object. But what if I want that object to have a method? What if I wanted to execute a function bound to that object? We can do that. So what we do, and there's a term for this, but I can't remember what it is. We can say, hey, here's a function. Bind that function to some type. And this is where Golang gets with the single variable stuff. Okay, I'm going to have some variable p, and that's going to reference the object that this is being called on. That p is going to be a pointer to a person. And I'm going to define a function called, let's just call it makeSound. There's a reason that I'm using such a weird name. You will see in a minute. And let's just return, hi, I'm p.name. Okay. Give everyone a minute to type this. This is something you will want to have on record. Let me also check chat. Am I missing anything? No. Cool. Yeah, there we go. If I do my windows like that, then I can see everything. Great. So what this is doing, this part in parentheses right here. Oh, wrong window. Here we go. This part in parentheses right here. This is basically telling it define this function as a method attached to this person object. Now, why is it a pointer? I don't remember. What's that?
If I want to change original one, then I can test.
Right, but in this case, this is being defined on the struct, not on the object, right? So when I create a new person object, that object will have this makeSound method because the method is defined on the struct. There is, I'm sorry guys, I looked it up last night, but I can't remember now, and I did not take note of it. There is a time when you don't want to define the function, when you don't want to define the method on the pointer, where you want to define it on the type directly. I don't remember when you want to do that, but I do remember that most of the time when I was running Golang, I defined it on the pointer of the struct. So I would say default to defining methods on the pointer of a struct. And if it doesn't act the way you behave, then try the value. But what we can do now is we can say my person dot make sound, and then we can print that, right? Okay. So that works much like object-oriented programming things. Make sense? All good? Cool. So, let's dive into, I'm going to break the order here, but this makes more sense anyway. So let's say, one of the benefits of object-oriented programming is polymorphism, where you can define some kind of base type, usually an interface, and then you can have multiple different implementations of that interface, right? So let's say I had a creature type, and then a creature could be a person, it could be a dog, it could be a bird, whatever. All of these things can make sound, right? And I don't really care which type of creature it is. All I care is that it can make sound. So creature is actually a bad one. Let's not call it a creature. Let's call it a vocal or vocalizable. Vocal. Usually when you define interfaces, you define it as a behavior, because actually, sorry, I'm doing things out of order. Let me define an interface and then I'll kind of explain that part. So let's go up top here. And let's define a new type, and let's call it audible. There we go. Audible meaning, able to be heard. And let's define this as an interface instead of a struct. And then we say that there should be some makeSound function, some makeSound method, sorry, that does not have any parameters and returns a string. Does that make sense? Everyone's got that? See some people still typing, looking up and down. Okay, looks like we're good now. So now what I can do is, down here, let's go ahead and define a new variable. Actually, let me follow my example. Yeah, there we go. Let's define not a person as an audible type. Okay? And then let's say that this is a reference to a person. And the name is totally not a person. And the age is 40. And then we can, you know, print it again. Cool. Does this make sense? I should have been walking around more. It's the bad part about having a fixed microphone. So, one thing to note. Why is this an error? Sorry?
A person is an instance of a interface.
Right.
And in the interface, there's no name attribute.
Correct. So not a person, the underlying object is a person, but the type of this variable is not a person. So as far as Go is concerned, I'm sorry, the type of this variable is audible. So as far as Golang is concerned, this is an audible, not a person. The only thing an audible has is the ability to make sound. Nothing else exists on an audible object. Even if the underlying object is a person, no go. Now you can get around this by doing a type conversion. You can do something like not a person dot person, I think, and then you can access the name. But the problem is that, you know, this has the potential to cause an error, so you need to do the type conversion, check the error first, and then you can access the underlying value. But we're not going to get into the details of that today. But this is how you do polymorphism in Go, much like any other language. Okay, so last thing before we move on from types and structs. We've talked about structs, but you can also do type aliases. So what we can do is I can make a new type called fancy int, right? And previously we did a struct, we did an interface, but in this case, I can just make it an int. I could declare a new type. Actually, that's it. I can just leave it like that. Okay. So I made a new type called fancy int, and it is an integer. Now you might be thinking, Beege, what the hell is wrong with you? Why would you do that? Right? Why would you make a new type that's just the same as an old type? Because I can do more. I can to remember. Yeah, there we go. There we go. It's an integer. 100% an integer. But it also has this pretty print function. Okay? That's some silly shit. You may not always want to do that, but you can. And so then I can call this. I can later say, you know, give me a new fancy variable, right? Its type is fancy int, and let's set it to 10, right? And then I can do fancy variable dot pretty print. Oh, oops, wrong thing. Wrong thing. Pretty interesting, right? You probably won't use this too often, but it is good to know about. Okay. All right, and now I'm sorry, I don't want to ask for questions because we're pretty much out of, well, we're over time now. But I want to show you the fanciest part of Golang. Oh, we're going to skip serialization. I'm sorry, but you can check the slides and I'll have sample code up later. It's also just like a common thing, you can Google it. But we're going to cover the coolest part of Golang, concurrency. And then we have one more tiny thing to do. I'm so sorry we're going over time. This was way too ambitious. But who here has heard of coroutines? 1, 2, 3, 4. Cool. So coroutines are used, I believe, in C. I haven't done much C and C++. And it's a way to basically execute a function in the background asynchronously in parallel. Right? So you say, hey, fire off this function, and then it goes and does stuff in the background. Right? This is how you do concurrency in C. In Golang, we don't have coroutines. We have Go routines, because gophers are funny. But they work pretty much the same way. Also, there is a primitive type called a channel. And a channel is a thread-safe queue. So what you can do is you can fire off a Go routine, right? You can basically call a function asynchronous, or kind of in the background, concurrently. You can call a function concurrently, and you can pass a channel to it. And then both your main thread and your Go routine thread can interact with that channel to pass data back and forth to and from each other. So let's say that you had like a job system where you wanted to like have a whole bunch of workers and then you delegate work to them and then they send results back to you, right? You could define a function and have it like give it like an input channel and then like an output channel, right? And then execute it as a Go routine. And then whenever you want to give data to it, you pass it to the input channel. Whenever you want to get data from it, you consume from the output channel. Additionally, you could do channel selection. Maybe you have multiple channels. This is very common, again, when you have something like a worker system or a queue system. But you also want like a graceful shutdown. So you want it to check two channels at once. And whichever channel gets a message first, execute that one. And that's often used for graceful shutdown. And then there's also the sync package, which you should definitely look into, but we're not going to have time today. So I'm going to make a new file. And I'm sorry, guys, I'm not going to wait for you to type because we are well beyond time. And here we go. So I'm going to call this concurrency. Then all of this will be posted online, so don't worry too much. And I'm just going to kind of copy and paste. And we're going to kind of review this together. So go run concurrency, yay. Okay, great. So, cool. So, I defined this function called say hi. Okay, this says hi. Why? So what I do is I randomly wait for some number between 0 and 1,000, and this is in milliseconds. Okay, so some number of milliseconds between 0 and 1 second. And then I'm going to sleep. I'm basically going to pause program execution for that amount of time. And then I'm going to print hi after whatever that number ended up being. Okay? So I'm going to have some delay, and I'm going to say hi after that delay. All right? And what we can do is, no. Just take me there, bro. No, I want to go there. Oh, because I have multiple references to it. That's why. Can I just, like, okay. I don't remember how to Visual Studio. I'm sorry, guys. Then if I want to execute a function concurrently as a Go routine, you just prepend it with the keyword Go. Okay? So what this will do is it'll fire it off in the background, and then program execution will continue. Okay? And then it'll just keep going. So what I did was I ran this, and then I ran a say hi synchronously, because I wanted to block some kind of time, and then I print finished. So what happens is, in this case, the first execution of say hi from here happens to just finish quickly. Then this one runs. Actually, I'm not sure which one runs first, but I'm just guessing because that's how concurrency works. And then finished prints. But I printed this 10 times. Well, it still printed 10 times. Just not in the order I expected, because that's how concurrency works. Okay? When you fire stuff off in the background, it just keeps running until it finishes, or until you tell it to stop with some memory safe communication. Okay? So that's how that one works, and that's how Go routines work. And then, I also said, hey, finished after waiting, because I just wanted to kind of make sure that I had something to break stuff. Now, I don't like this example, but this came from the documentation. So this is an example of a channel. Again, you can think of a channel like a thread-safe queue. Okay? So, similar to slices and maps, you create a channel using the make function. And in this case, a channel has a second type, basically the data that you will send along that channel. Okay? So in this case, this is a thread-safe queue, also called a channel, that I can send integers through. Okay? And then I have this sum function, which is going to take some amount of... I hate that they did this. It basically takes the values from this slice and then divides them all by 2. Oh, no, I'm sorry. This passes the first half of the slice to a sum method, and this passes the second half of the slice to a sum method, and then it passes this integer channel to both of them. Okay? So basically what we're doing is we're taking the slice, we're splitting it into 2, we're adding the sums, okay? Or each of them is going to sum up. And then we're going to pull that data off of the channel. Okay? So we declare the channel here. We pass it to our sum function. So our sum function now has the channel. In our sum function, we basically, we add up all of the values that we got, and then we send that sum function back, or we send the summed values back through the channel. Okay? So basically we said, hey, here's a communication pipeline, go do your thing. And then it went and did its thing that sent back the sum through that communication line. Okay? And then we pull off, remember, we split the queue in half, we split the slice in half and had 2 sum executions. And then we basically take we basically pull data from the channel for both, and we set them to X and to Y. Okay? And then we print to X, we print Y, and we print X plus Y. And what will happen here is, X will be some random number, not random number, but will be some sum of those numbers. Y will be another sum of those numbers. And then together they're 12, because if you add all these together, they're 12. Actually, no, that's going to be deterministic, which kind of sucks because it defeats the purpose of it. But anyway, you can see here how you can kind of delegate tasks. Rather than summing the whole array at once, or the whole slice at once, we split it in half, ran the sum concurrently in 2 different ways, and then we grabbed the results from those 2 threads. Yeah, this example sucks. I'm sorry. What parts of that don't make sense to people? Because I see a couple of faces of confusion. Concurrency is nuts, guys. So basically, I wish I had a whiteboard. Shit.
We're just splitting it into a tree of 2, and then
Yes.
and then speeding the process up twice as fast because you're doing it twice as fast.
Yes. Thank you. That is a good explanation. So I said it's splitting the array into a tree of 2, and then basically doing the processing concurrently, and then kind of joining it at the end. Yeah. So.
What you can, another example,
Mm.
which like I was doing, for example, is if you grab data from like a topic from like a RabbitMQ or Kafka or whatever,
Mm.
and you're grabbing data that is like currently updated,
Mm.
then you can just have that in a Go routine, and in your main thread or whatever,
Yep.
you can just grab some data always and make it available somewhere else
Yep.
in another topic or
Yep.
transfer it.
So for benefits of the stream, I'll kind of restate what you said. If you have something like you're pulling from a message queue, you could have kind of the main thread listen to the queue, and then as messages come in, fire off Go routines to do work with that and maybe send to other queues. Great example. Another very common example, let's say you're building a web server, right? You have a main thread listen to the WebSocket, and then as a request comes in, you fire off a thread to handle that request, and then you can handle a bunch of HTTP requests concurrently. That's how pretty much all web servers in Go work. So yeah, and then you can also make a channel have a capacity, and that way you can actually force a channel to block. Because when you normally work with channels, they're not blocking, right? You get data, you give data, and they just kind of don't block so much. But here, if I what I can do is I can put 2 values. So the channel has a capacity of 2. I can put 2 values on the channel. If I put a third value on the channel, depending on the context, it will either block until something else takes something off of the channel, enabling or freeing up capacity, or in this case, what will actually happen is it'll panic because there's no way for the channel to be unblocked because it's all hard-coded here. Okay, so that's another thing. You can make channels blocking if you want to control flow. This is very useful with things like a graceful shutdown. And then you can also continuously read from a channel. So let's say, like, with the message queue thing, let's say you get a whole bunch of messages on a worker, and then when the worker is done, you want to find out. Well, what you can do is you can use range to continuously pull. It'll keep looping. Well, you have a for loop. You keep looping, and then the range will continuously pull from the channel until the other side closes the channel. You can call a close function on a channel, and that'll basically say, hey, I'm not accepting any more messages. We're done. And then range will detect that and be like, okay, I'm looping on this channel. Oh, the other side closed it. Okay, I'm done looping. I can continue the program flow. Okay? So that's really nifty. And then selecting channels. This one is really useful for graceful shutdowns. So let's say that I want to run the Fibonacci sequence, but I also want to be able to quit. What I can do is I can have a loop where I continuously do my work, right? Again, you'll see this with like a web server, or you could do it with message queues or whatever. And for my normal message queue, right, where I'm normally getting messages in, work to do or whatever, I can just, basically, wait, this is backwards. Yeah, they're pushing stuff into the queue. That's weird. Whatever. You can that's right, because they want to read. So in this case, they're pushing stuff into the queue, right? Unless the quit queue, which is they're pushing information into the channel, unless the quit channel sends them a message like, hey, you should stop now, right? And what will happen is this loop with the select, every time the loop runs, it'll check this channel. If there's data for it, it'll pull from it. Otherwise, if there's something coming in on this channel, it'll be like, nope, I should execute this instead. Okay? So this is how you can do a graceful shutdown, because when you send something on the quit, the other channel will be ignored, and then this will run, and you can terminate the loop. Does that make sense? Cool. And then the last part that we'll cover today is building. So the really nice thing is that Go allows you to cross-platform compile. So you may have noticed I'm running here in I'm running in WSL, right? So if I want to do I'm on Linux, right? So Linux file system, all that sort of good stuff. I can do go build main.go, and it'll produce this main executable. Okay, this is a binary, and it is because I built it on Linux. I can execute it on Linux as a binary. And it prints all the stuff that we did earlier. Cool, right? However, I could also, if I set the Go OS to Windows, and actually let me make sure I get this right. And if I set the Go architecture to AMD 64, because I have a 64-bit computer, and then I do a go build main. I haven't tested this, so let's see if it works. Okay. Main.exe, right? And then I can move this over to my C drive, and I'll just put it in my C drive. Oh, that's cool. Wait, what? Why? What? What the hell? All right. User. Users. Oh my god, I cannot type. What the hell is my username on this? Oh god, yeah, I got this a long time ago. And then let's not do documents. Yeah, let's just do the root. So let's move it there. Great. And then, crap, now I have to, I'm not sure what file is where. So let me go to my home folder. Shit, where's my home folder? That is on Linux. There we go. Nope, that's my other partition. Sorry guys, my computer's a mess. There we go. And then I can run a shell here, right? New shell? No? Fine. Command. There we go. And then I can run main.exe. Voila. So cross-platform compile. It's awesome. And this is one of the main things with Golang. And the way I was able to do that, nothing special, nothing fancy. Let me keep my system at least a little bit clean. I don't need this anymore. You know, all I had to do was modify a couple of environment variables. I just had to say that, hey, the OS that we're building for is Windows and the CPU architecture is AMD 64. Done. Then I just do go build as normal. You can also do all sorts of other stuff. You can include, you know, different linkers and all that kind of stuff. You can specify the output binary name, all the standard stuff. But I just wanted to demonstrate that part because it's really cool. So there are a bunch of websites to learn more. I strongly recommend A Tour of Go. A lot of this was based on A Tour of Go. The channel stuff was pretty much copied straight from there because I was running out of time. There's also Go by example. And the Go documentation is actually really good. And lastly, there's a Go playground where you can just run this code online. I might have had ulterior motives asking you to install it on your computer. But also running with an IDE is a little bit nicer than writing on the Go playground. So that's where you can go to learn more. These slides, I'm going to share them in our Discord, and they will also be linked. I think they're already linked in the YouTube channel video stream thing. So yeah, thank you guys for your patience. I'm so sorry we went way over time, but we're going to have chicken. Code Soul pays for it, so I will pay you for your extra time, basically, in food. We covered what is Golang. We covered when you should use Golang. We went over how to set up a project, which was hopefully very easy for you. We went through basically all the language features of Golang for normal programming stuff. We also talked about types and structs. Unfortunately, we had to skip serialization, but you can check the slides out for that. It's quite simple. And I'm going to upload the code that we did today with some minor modifications later as well. We also went over concurrency, building, and where to learn more. So questions. Let's talk about questions at dinner. And also, we include image credits for all the images that we have here. A lot of them actually came from interesting blog posts about Golang and how to do interesting things in Golang. So in addition to those other links that I shared earlier, I recommend checking out the image credits at the bottom of the slides. And that's pretty much it. So thank you very much for your time. Again, I am super sorry we went so long over. But I hope it was useful for everyone. And online folks, I hope you had a good time too. Let's go get some chicken. All right. Bye, Internet.